Now, I'm sure you've seen me do a lot of stuff with compressed air, especially making compressed air engines. But one thing I haven't really seen a lot of is finding ways to compress air using 3D printing. So then this got me thinking of how I was going to design something to actually compress air, and this is what I came up with. It looks a lot like the 3D printed gas engine, but I did make a few changes, like a print-in-place crankshaft, and a piston with 2 O-rings instead. Now while you're watching me put this together, I just wanted to explain that the reason for having the 2 O-rings is actually because it's going to be subject to a lot higher compression, so I just want to make sure that it's not going to leak around the piston at all. Now thankfully, the head is going to be nice and simple. It doesn't actually need to have any valves that are going to be manually opened and closed like any other engine does. Instead, I'm going to use airsoft BBs and some O-rings to create check valves. One will be used for the intake, and the other is going to be used for the outlet. Now this is going to be the head of the compressor. And with O-rings placed on opposite sides, it means that one is going to act as an inlet and the other is going to act as the outlet. And just to make sure that no air is going to leak around the head, I'm going to add some silicone to the top of the head. And then the head can be put together. And after all the screws are threaded in, the last step is to add the outlet hose. Once again, just to make sure nothing's going to leak, I'm going to put some JB Weld around it. And now it's time to work on the cylinder. Instead of using the O-ring head gasket that I was using before, I am just going to seal it with some silicone, because it is going to be subject to higher air compression. Also, I just trust that actually gluing it with silicone is probably going to do a better job than just an O-ring would. Once the head is put on the cylinder bank, we can actually start putting the compressor together and have a first look at how it's going to work. And just like before, I'm going to be applying some grease to the inside of the cylinder walls and around the rings of the piston. Now without me being too repetitive, this is what the final compressor looks like. Now just from me spinning it, you can hear that it actually has a lot of compression. Well, let's actually find out exactly how much it has. And to do this, I'm going to dig out something from an old project. You might remember this turbo from another project video. I'm going to borrow its boost gauge, and that's what we're going to use to find out how much pressure this generates. I'm going to connect the outlet line right to the back of the boost gauge. Even though I'm using just my hands, with a really good throw, it seems to make upwards of about 13 psi. Now I thought it would be a good idea just to do a quick test off camera to see how it would work, and that would turn out to be a huge mistake. Alright, so let's have a look at the carnage and see if it looks as bad as it sounds. And it seems like the print-in-place crankshaft might have actually been a mistake. Now because the print-in-place crankshaft was printed on its side, this allowed it to be torn apart very easily. Now I know I've said before that using a print-in-place crankshaft is actually a bit better and it's more convenient. But because this only has one cylinder, and it only has one thing actually on the crankshaft, it makes more sense to make this a 2-part crankshaft, because it will be actually stronger. Because of all the shards of plastic that were thrown around, I'm going to take the engine down, clean it up, and then I'm going to rebuild the whole bottom end. And I'll get back to you once it's finished. Right, so after putting it back together, I've actually gone ahead and I put a water bottle to the end of the outlet hose. This water bottle is going to serve as our air tank. So you can hear that it is clearly working, and if you look closely at the water bottle, you can see that there's a lot of moisture building up from the compressed air. It's generated enough pressure that the bottle actually sounds rock hard, and when I open it, quite a lot of air escapes. Now even though you can see that it was working, I am a little bit disappointed. It seems like once it reaches a certain pressure, it actually stops compressing, because the valve won't open anymore. Now I could have just cut it here and then moved on, but then I had an idea. And that idea was to convert it from a single cylinder to a V-twin compressor. In order to save time and resources, I've simply just reused a lot of the old parts and only made a few new ones. All it really needs is just a new block and a second cylinder. And it's already starting to take that signature V-twin form. Now the outlet line from the first cylinder is actually going to be feeding directly into the intake of the second cylinder, and after putting JB Weld on the intake and the outlet hose, it's finally finished. All it needs is just the front plate. Now this new compressor here has what's called a compounding setup. Air is compressed into the first cylinder, and then from this line it leads into the second cylinder, which is then compressed again, and then it goes out the outlet. Essentially what this is doing is it is actually doubling the amount of pressure that is available, because it's compressing it from one, compressing it into another, and then it is leaving through the outlet. Now let's have a look and see how much I can pump into this water bottle with just using my hands. Now it already does feel like it's pumping a lot more, but listen to this. Now I'm actually really happy with it. It seems like only with my hand I can actually get it to compress a pretty good amount. So let's actually have a look and see how well it works. Alright, so it's in the bench vise now, but I've also included the boost gauge onto the water bottle so we can actually see how much pressure it's building. Once I made it to about 8 psi or so, it actually started to hurt my finger, so let's switch to a much better alternative. If we have a look at the boost gauge, you'll see that as the pressure increases, it starts to slow down, and this is because the pressure inside the cylinder is starting to equal the pressure inside of the water bottle. So what begins to happen is that it can't actually exit the cylinder, and then it kind of hits a state of equilibrium. Although I still decided to push it upwards of about 20 psi. Wow. So the water bottle developed a leak around where the hose meets the cap, so it won't reach anything higher than 15 psi. One of the uses I was thinking of was actually using it to compress air for another compressed air engine, although I think that might be a little optimistic. Now, if you can think of any suggestions that you want to see me do with this thing, let me know in the comments down below. I'd actually really love to read them. But until then, I think I'm just going to leave it on the shelf with the other ones. Thanks for watching.